Welcome back to the picture of the notes on the tray. Thank you for turning in your work, and please continue to do so through Google Classroom. The lesson for today is called Lines of Best Fit. This goes into our data and statistics unit, which we wouldn't get to till the very end of the year, but this is something that you do need to be familiar with for IAR. So our focus today is with scatter plots and how to define and use lines of best fit when comparing two quantities. So first of all, we're going to be looking at what's called a scatter plot. And a scatter plot is a graph that shows the relationship between bivariate data. What that means, bi, that prefix you should know means two. So data with two different variables. So these graphs are going to look a little bit different than the graphs that we've been working with our independent and dependent variables. Now, the focus of a scatter plot to kind of pinpoint your data and make predictions is creating what's called a line of best fit. A line of best fit is a line that is very close to most of the data points. So this isn't going to be a line that's constructed off of all the data points. Sometimes it might not even hit any of the data points, but it is very close to most of the data points. And you're going to see what I mean as we look at the two examples in your notes here. So the first example is for you to construct a line of best fit. In order to do that, we're going to follow two steps. Okay, once you have your data plotted, and this graph already came with the data plotted, we're comparing points earned in the years since 1999. And this scatter plot is yearly points scored by a certain race car driver. So that's just the background. So make sure you write that in. You're going to notice that the points don't form a line. They're just kind of plotted all over the coordinate plane, and that's why it's called a scatter plot. They're just kind of scattered and plotted. So in order for us to construct a line, we're going to follow two steps. Half the points need to be above the line, and half the points need to be below the line for this to be an accurate line through our scatter plot. So halfway, you can kind of count on your points, and you do the best job that you can. You can see in the line that I drew that starts a little bit above the 3,000 mark, and I actually do touch the point that's close to that. I use my straight edge, of course. There's more above than below, but you try to do as best you can, half and half. And then with scatter plots, most of the time you're just making a conjecture about the points the driver will score in 2015, making a conjecture about the graph, and a conjecture is just a guess, an educated guess based on the data. So in looking at this data, how many points will the driver score in 2015? So looking for 2015, and after drawing my line, I kind of circled where that would be. The points a driver will score in 2015 is about 5,900. So you're estimating, you're making a guess based on the line that you're drawing through your scatter plot data. If your guess, is close, let's say within 100 either way, that would be fine, okay? So that's just drawing the line. The next example we're going to show you is actually plotting the points to make the scatter plot. You can see I made a mistake, and if you notice any other mistakes, please let me know. As you know, I frequently do make mistakes. How do I write an equation in slope-intercept form for a line of best fit? Okay, so again, this one was already created, so you're actually not plotting the points this time, but this scatter plot is not as scattered as the last one. They do kind of form a line, and what we want is an equation for this line. So when it is close like this to where they are almost aligned, then you can write an equation. We learned about slope-intercept form before the holiday break, I think. So hopefully you haven't forgotten. Slope-intercept form is y equals mx plus b. Very good. M stands for slope, yes, and B is your y-intercept, and y-intercept is where it crosses the y-axis. So what you need is you need your slope and you need your y-intercept from this line. All right, so to find slope, hopefully you remember the formula for slope. M equals y sub 2 minus y sub 1 equals x sub 2 minus x sub 1. Yes? You're all saying yes. You need 2 points on the line. So you're going to choose 2 points on the line. They may or may not be data points. They might just be points that go through the grid. I chose 9 and 275, which is here. And you can see that that's actually not a point that was part of the data. And then I chose 7 and 225, which is a point. It's very close to that line, but it's not exactly on it. Okay, so you can choose points that are on the line that you make, or you can choose actual data points from the scatter plot. Choose 2 points, put them in your formula for slope, y2 minus y1, x2 minus x1. I'm doing my math here. Negative 50 over 2. A negative and a negative make a positive, so 25 over 1 is my slope. And then use the graph to find B, the y-intercept. Look at your y-axis. Where does it cross? Again, this is going to be an estimate. I'm estimating that to be at about 80. And see, I did my little wigglies to say it's not exactly 80, it's about 80. Got my formula, y equals mx plus b. So y equals 25 over 1x plus 80. Getting an equation from a scatter plot then allows you to also make a conjecture about what will happen in future years. For this one, it's years since 1999 and subscribers in millions. So we figure maybe it's a magazine or newspaper or something online, that sort of thing. This equation would allow us then to make a conjecture for past 10 years. Okay, that's scatter plots. It ties in nicely to some things that I've already taught you. See what you can do with the practice online. If you have any questions, please email me. Good luck.